how well do we really understand the spread of the current pandemic? To comprehend this, we explore the transmission of the coronavirus, the significance of social distancing, and the crucial role of air conditioning systems in mitigating virus spread. Welcome to the Coronavirus Dispersion CFD Simulation Training Package by ANSYS Fluent, a compelling tool that models these elements, helping us visualize and better grasp the complexities of this pandemic. Let's dive into the 10 practical exercises this training package offers, shall we? The first exercise takes us into a hospital room. We're simulating the airflow from a COVID-19 patient's mouth in a space equipped with ventilation and air conditioning systems. This exercise shows us how the virus might move about in a controlled medical environment. Next, we take flight with exercise 2. This exercise models the spread of viral particles from several passengers within an airplane cabin. The setup includes a detailed airplane and passenger model. With this exercise, we get a glimpse of the challenges in preventing virus spread during air travel. Exercise 3 brings us into a common everyday scenario, the elevator. It's crucial to understand how the virus spreads in small, enclosed spaces with limited ventilation, like most elevators. This exercise provides valuable insight into these high-risk situations. This simulation reveals the risks associated with using elevators during the pandemic. The remaining exercises take us through a variety of other scenarios. Exercise 4 presents a simulation of virus spread within a car. This exercise particularly emphasizes the role of air conditioning systems and how they can both help and hinder virus transmission. The fifth exercise focuses on classrooms. Here, we explore how the virus spreads among students and the potential role of protective measures like desk shields and masks. In exercise 6, we delve into the world of restaurants. We investigate how the virus can move from table to table and how proper ventilation and seating arrangements can mitigate this risk. Exercise 7 takes us into the realm of stadiums. This large, open space presents unique challenges and opportunities when it comes to virus spread. The 8th exercise brings us back indoors to the setting of a clean room. Here, we delve into the intricacies of air filtration and its role in preventing virus transmission. For exercise 9, we explore a more complex scenario, a multi-story building. This simulation reveals how the virus can travel through ventilation systems and spread between floors. Finally, in exercise 10, we examine the open-air environment. This simulation sheds light on how factors like wind speed and direction can influence the spread of the virus. These exercises provide us with a comprehensive understanding of how the virus spreads in different environments. So, what have we learned from these exercises? We've discovered how simulations can help us understand virus spread in various environments, from hospital rooms to airplanes and elevators. This understanding is crucial in making informed choices to safeguard our health. With this knowledge, we can make informed decisions to protect ourselves and others during this challenging time.